Hello everybody. In this lesson I will discuss grade 12 probability, more specifically repetition and selections. This is lesson 3 of 5. Let's consider the word Bob. There is 3 factorial ways of arranging the letters. In this case, if the places of the B's were swapped, the word would still be Bob, and it would not count as a different arrangement. In order to account for the repetition of letters, we divide 3 factorial by 2 factorial because the letter B is repeated twice. In other words, the number of arrangements will be 3 factorial divided by 2 factorial, and then the answer is just 3. Now this brings me to rule 2. If the letters of a word with N letters contain P and R identical letters, then we can form N factorial divided by P factorial times R factorial different words. Example 1. The letters of the word seeded are arranged to form 6 letter words. The repeated letters are identical. How many different words can be formed using these letters? The words do not have to mean anything. Now, since there are 6 letters, they can be arranged in 6 factorial ways. This is equal to 6 times 5 times 4 times 3 times 2 times 1, and this is 720 ways. However, the 3 E's are identical, so there are 3 factorial among the 720. Similarly, the 2 D's are identical, so there is 2 factorial among the 720. These identical arrangements must be cancelled out. Therefore, seeded's different arrangements will be. Now remember, our little formula on the previous slide was n factorial divided by r factorial times p factorial, where r and p are the letters that repeat. So therefore, 6 factorial is the 6-letter word, and then 3 factorial, this implies it's the E's, and 2, that's the D, 2 factorial, the D's. Therefore, 6 factorial divided by 3 factorial times 2 factorial, and then that one you can slot it in your calculator and you can give me the answer. Or what I did here was I said the 2 and the 2 will cancel and the 3 and the 3 will cancel. You multiply everything, divide, and your final answer, 60 words. Example 2. Given the word probability. Number 1. Determine the number of different ways that the letters can be arranged. The letter B is repeated twice and I is repeated twice. Therefore, the number of arrangements is equal to 11 factorial. That's the total number of letters you find in the word probability. And then there's the letter B. You can see once, twice. Therefore, there's a 2 factorial under the line. And then the I. There's 1, 2 I's under the line, another 2 factorial. And you work that out with your calculator and you end with 9,979,200. Question 2. If the word has to start with a B, how many different ways can the letters be arranged? So now, in the first little pigeonhole there, you fix the B. Then, do you agree? Suddenly, there's 10, 9, etc. letters available. So the first letter is fixed, therefore there are only 10 choices left, etc. The letter B is then also not repeated and only I is repeated. Therefore, the number of arrangements will be 10 factorial divided by 2 factorial. And this 2 factorial, this is for the letter I. And your answer, 1,814,400 different number arrangements. Example 3. Consider the word dimmers. Number 1. How many word arrangements can be made with this word if the repeated letters are treated as different letters? So then you count how many letters you find in the word dimmers. There's 7. Therefore the answer 7 factorial. And you work that out with your calculator and the answer is 5,040. Question 2. How many word arrangements can be made with this word if the repeated letters are treated as identical? So now it's your little formula. Therefore, do you agree? It's 7 factorial divided by 2 factorial. Where does the 2 factorial come from? That is the 2 m's that repeats. And when you work that out, you find the answer 2,520 different arrangements. Question 3. How many word arrangements can be made with this word if the word starts and ends with the same letter? Now, do you agree? There's 7 letters. 1, 2, 3, 4, 5, 6, 7. And then the words or the letters rather that repeat in the word dimmers will be the M and the M. So do you agree there's 5 spaces left or 5 choices? Therefore the answer 5 factorial, and that is equal to 120. Question 4. How many word arrangements can be made with this word if the word starts with D and ends with S? There's your word dimmers. So do you agree if it starts with a D and it ends with a S, it's as if you cancelled them out. And then you're left with 5 letters, so 5 factorial divided by, and then there's the 2 factorial. That means it's the 2 m's. And your answer will be 60 different arrangements. Let's look at the discussion. In how many ways can 7 seats be filled by 10 different teachers? Now there's your 7 seats. Now do you agree? 10 different teachers can only occupy 7 seats in the following ways. 10, 9, 8, 7, 6, 5, 4. So how do we write this? Only 7 seats can be occupied. In other words, to find the answer here, do you agree that can be represented as 10 times 9 times 8 times 7 times 6 times 5 times 4? And then originally there were 10 factorial divided by, and then there's the 3 factorial because that's what's left. There's no seats for them. Then we can write this as 10 factorial divided by 10 minus 7 factorial inside a bracket. And this brings me to rule 3. The number of arrangements of n different things taken r at a time is given by n factorial divided by n minus r inside a bracket factorial. Example 4. There are 12 F2 drivers that are hoping to win the first 3 places in a race. In how many different ways can the first 3 places be occupied? Now, there are 12 cars to be arranged in 3 different ways. The possible arrangements are, do you agree, 12 times 11 times 10. Now this is the same as 12 factorial divided by 12 minus 3 factorial. And then your answer will be 12 factorial divided by 9 factorial. Therefore, the answer, 1,312 different arrangements. Example 5. A roller coaster has 5 vacant seats. In how many ways can 11 children occupy the seats if only 1 child is allowed per seat? So I think by now you understand. Using our little formula, n factorial divided by n minus r factorial. And then here's a tip for you. N is the big number there, and then again 11 minus, and that's the 5 vacant seats. Therefore, our answer will be 11 factorial divided by 6 factorial, 55,440 different ways. Example 6. A university has 6 open spaces for veterinarian studies for next year. If there are 14 applicants, in how many ways can the applicants be chosen? Again, there's our formula, n factorial divided by, in a bracket, n minus r factorial. N is the big number, 14 factorial divided by 14 minus 6, this open spaces, equals 14 factorial divided by 8 factorial, and the answer 2,162,160 ways. Example 7. A frozen yogurt shop offers 15 different toppings. If you have to choose 4 toppings, how many different frozen yogurts can be made? Do you agree? Our formula, n factorial divided by, in a bracket, n minus r factorial. Therefore, n is the big number, 15 factorial, divided by 15 minus 4, the different toppings, equals 15 factorial divided by 11 factorial, and your answer, 32,760 different frozen yogurts can be made. In the next lesson, I will discuss 6 questions from previous exam papers. Click on the video in the left-hand corner to take you straight to the next lesson.